Okay, now, what we're going to talk about now ultimately is dealing with polynomial functions which don't ordinarily factor. Okay, so that's going to be the goal, or at least don't factor by ordinary means. Okay, so let's just start by looking at some polynomial functions. This, of course, is polynomial function, which is in nice expanded form, or I'm sorry, in factored form, which offers to you quite easily the x-intercepts at 1, 2, and -3. All right. Now it also offers you the y-intercept because if x is equal to 0, this group just becomes -1. This becomes -2. -1 times -2 is 2, and then that times 3 is 6. So that should be 6, not 9, as the y-intercept 6, right? Okay. Now. Um, Not that we would need to do this, but we're going to multiply it out anyway. Okay, so we're going to multiply out that polynomial. And of course, here it illustrates that the y-intercept is 6, as it should have been corrected up here. Okay, um, so if it's multiplied out, this is what it would look like. Now, okay, preferably, this is nice for graphing because you have the intercepts. You know that it's going to multiply out to an x cubed, and you know the general shape. Okay, but if it's given to you in this form, okay, the y-intercept is available, but the x-intercepts are not. And furthermore, how would you ever get back to these factors? Okay, so that's going to be part of the problem because this is not going to be factorable by any means we know at this point. So that's what we're going to be discussing. How would we be able to return this to a factored expression? Again, since this one multiplied out gives us this cubic when factored should give us these factors and enable us to graph it. So the objective here is going to be illustrating some ways in which we can factor this, okay, uh, by some means of long division or synthetic division is what we're going to learn, okay? So continuing on. So the one thing I want to pay attention to here, we notice that the x intercepts were at 1, 2, and 3. We notice that the y-intercept is at 6. Now it's by no accident. It's by no accident that, okay, among all the factors of the y-intercept, we will find the x-intercept. Okay, so 1, 2, and -3 are all factors of this y-intercept of 6. Okay, so by no accident will we find that within the y-intercept, we will find what our x-intercepts are. Okay, and if we have one, then we can find the others. Okay, so as I said here, notice that among all the factors of the y-intercept in this expanded expression, we will find the x-intercepts, and this is by no accident. We should agree that if there's an x-intercept of 1, then there's a factor of x minus 1. Okay? If there was an x-intercept of 2, there's a factor of x minus 2. If there is an x-intercept of -3, there's a factor of x minus -3, or mainly x plus 3. So that's what we're saying down here. We should agree that if any of these factors, let's just generally call them x equals a, okay, is an intercept, okay, then the factor must be x minus a. And furthermore, okay, even more importantly, is if if we have an x-intercept, the function evaluated at that x-intercept will always give 0. Obviously, come back here. We knew the x-intercepts uh, when factored were 1, 2, and 3. What is the function evaluated at 1? 1 minus 7, which is -6, plus 6 is 0. It is equaling 0, okay? What is the expression evaluated at 2? It's 2 cubed, which is 8. 8 minus 14, which is -6, plus 6, which is 0. So two very, very important items to take note of here. Actually, three. Okay. First, the x-intercepts will be among the factors of the y-intercept. My x-intercept here was 6. All possible factors, 1, 2, 3, and 6, all going plus or minus, plus or minus. So there's 12 possible factors, okay? Okay, if one of those values, x equals a, is an intercept, then two things ring true. The function evaluated at that value is 0, and the factor is x minus a. We've got to bear that in mind with what we're going to look at. Okay, now let's consider trying to find a graph of this guy, this cubic expression. Okay, it is not going to factor on the ordinary means. Of course, when they're all mixed up, you're going to want to see if it will factor under ordinary means, but it will not. Okay, so what we do here is take note. If we wanted to graph this, we would like to have the x-intercepts, obviously. You should agree that it will have at least one x-intercept because it is a cubic. Yes, it should have at least one. Okay, so it should have at least one x-intercept. What are those possible values for the x-intercept? Well, okay, uh, again, we note that traditional factoring methods will not work, okay? As we stated previously, that the x-intercepts are locked up in the y-intercept. The y-intercept is 2. The y-intercept is 2. So the x-intercept is locked up in there, plus or minus 1, plus or minus 2. Thankfully, that's a prime number, right? So among the values we want to try, okay? Plug in 1, plug in -1, plug in 2, plug in -2, okay? All right, we know that this could have at least, at most 3 factors, but at least 1, okay? So, again, from the previous page, if we can evaluate the function at one of these values and it produces 0, okay, then we know we're going to have a factor, all right? So, let's see what happens when we do this, all right? That's the note right there, okay? F of -1, -1 plugged into the function, -1 cubed, which is -1, -3 times -1, which is 3, does not equal 4. Stop. That means x equals 1 will not be a factor. Okay? X equals 1 will not, x equals -1 will not be an intercept. X minus x plus 1 will not be a factor. What happens when we try 1? When we put 1 into the function, 1 cubed 1 minus 3 plus 2, bingo, that goes to 0. That produces, since f of 1 is 0, okay, x equals 1 is an intercept, and x minus 1 is a factor. Okay? Again, all the possible values of factors of the y-intercept will be values that we want to try plugging into the function to see if they produce an x-intercept. Plugging in -1 did not produce a 0, so that is not an intercept. Plugging in 1 does produce 0, so x equals 1 is an intercept, and x minus 1 is a factor. Okay? We had you view Mr. Kahn's method of long division. It's not his method, but he illustrated some long division. So we should agree that if we have one factor, long division into this polynomial should produce, okay, a quadratic. This is a cubic divided by a linear. The result should be a quadratic, and hopefully from that. And if you're a varsity football player, you must leave now. Although I'm still here recording this just for you, okay? So here we go. Let's do the long division, okay? X minus 1. You need to go back and look at Mr. Kahn's, okay, videos on doing the long division. We'll have practice with this in class. X into x cubed. Now, the big thing here is since we did not have an x squared term, we need to fill in a space. We need to fill in a space. We need to account for all diminishing powers of x. So there's no squared, so we put in minus 0x squared. We could have put plus 0x squared, make no difference, okay? The term is 0. X in the x cubed goes x squared times x is x cubed, x squared times -1 is -1x squared, okay? Subtract, do the subtraction, first term disappears, 0 minus a minus 1x squared is plus 1x squared, bring down the next term, okay? X into x squared now goes x 1x times plus 1x. 1x times x, x squared. 1x times -1 minus 1x. Draw the line, do the subtraction. Okay, x squared term disappears. All right, bring down the next term. Last round of division. X in the -2x minus 2. Minus 2 times x minus 2x squared minus 2 times -1 plus 2. Draw the line, subtract, nothing left, divides evenly. So guess what? Okay, we have factored this. Okay, we have factored. Okay, through trial and error, we found that x minus 1 was a factor. Through long division, we found that the other factor was x squared plus 1x minus 2. So therefore, this thing, as you can see, has been factored into x minus 1, the quantity x squared plus 1x minus 2, which again, that's a trinomial, so that factors quite easily as x plus 2, x minus 1. Since x minus 1 appears twice, that's a multiplicity, okay? So finally, our graph will have intercepts at -2 with a multiplicity at 1. And so you should now know how to graph those. That's what we focused on before. At this point, the focus was on trying to get the factors so that you could proceed to factor, okay? We'll look at another example in another video. So we'll stop this one here.